please welcome Jules Paris, Director of Core R&D at JMP.
Good morning, everyone. As Jeff said, today is all about guiding principles, those things that have been with us since the beginning. And speaking of beginnings, I want to start today by actually telling you the very real story of the very first time that I opened JMP. So I want to set the stage. This is my second year of grad school. There I am in my basement office, no windows. And I was just browsing the university's website that showed all the software that's available to us for free because the university licenses it. So I'm looking through the data analysis and visualization section. I was a nerd back then too. And I found a piece of software I'd never seen before. It was pronounced JMP. I didn't know at the time that you're supposed to pronounce it JMP. Sorry, John. It's not totally my fault. There is no vowel in it. So did anyone else make that mistake when they first saw JMP? Yeah, thought so. John has this joke. I'm sorry, I'm going to steal it, John. Why does JMP not have a vowel in it? Because it needs you. Anyway, John does it better. Anyway, so I downloaded and installed the software, installed quickly, and then I was going to open it for the first time. And I really wanted you all to experience this with me, so I brought the MacBook I had in 2006. Unfortunately, we couldn't get it to connect to the projector because it didn't recognize the projector. It's too old. So instead, I did a screen recording, and this is very legitimate. So again, 2006, set the stage. And so there I am on my MacBook in my windowless office. And I figured the thing I should do is open some data I'd seen before, so I can make the comparison. And so I took the CSV of, this is some of my master's thesis research data, dropped it right on top of JMP, and it opened up right away. I was doing great. Data table looked cool. I liked that I had the variables on the left-hand side. That was different. I was an SPSS user, I know. So JMP was a little bit different right now, but I kind of got it. It made sense. Now, I had done some regressions for my master's thesis, so I figured the thing I should do is let's go do some linear regression, and I'll see how it compares and what the output looks like. And so I saw an Analyze menu, and I thought, OK, I'll go there. I'm going to look for linear regression. I got to the Analyze menu. I didn't see linear regression. Like I said, I came from SPSS. All those tools were listed out by name, and there was nothing there. So I figured, OK, what's closest to that? Well, fit y by x sounds a little bit like linear regression. It's 1y and 1x. And so I got to that menu item, went into it. I kind of figured out, OK, I need to designate some variables. So I scrolled down to some variables that I was using. I was studying some things to do with, that doesn't really matter, fun master's thesis data. And I figured I'm going to click the OK button, and I'm going to get a bunch of parameter estimates, p-values. It's going to look just like the kind of output I saw before. So I click that OK button, and I get a scatter plot. I didn't even get a fitted line. I was confused. I was actually a little bit frustrated. I didn't really realize how to move forward. I probably said, or actually I know I said, some fairly ungenerous things about JMP at this point. Again, sorry, John. But again, windowless office, hadn't been outside in days, was probably low in vitamin D. And so, I was a little bit frustrated. But the truth is, I didn't know how to think like JMP thinks. I didn't understand the idioms of the software. And I was stuck because I felt confused and like I was being misunderstood. Now, fortunately for me, this following summer after that experience, I switched advisors, and that advisor was a longtime JMP user. And he was able to explain to me in 10 minutes the concepts I was missing. And then I really fell in love with JMP. It was really quick, once I understood how to think like the software. I loved it so much that the following summer, when I got offered my first statistics class to teach, I decided I was going to teach with JMP. But I didn't want students to feel frustrated like I did. And so in that class, that was the first time I taught a section called The Mind of JMP. My idea was to give students an understanding of the way that JMP thought about data and thought about, how you should use it. And by knowing the mind of JMP, you could expect and understand what JMP expects from you in order to communicate well with it. And so that lecture, that was sort of like what we're doing today. I was speculating from the outside about all those principles that led to how JMP thinks about data and how JMP thinks about statistics. And so this morning, that's what we're digging into. We're going to dig into that mind of JMP. And fortunately, I have some people here who were there on that fateful day in 1989 when the first copy of JMP was released to help us understand the mind of the software. So I'd like to invite to stage our founder and chair, John Saul, and back to the stage, Jeff Perkinson, our Director of User Enablement. Come on up here. Jeff, you changed.
Yeah, I'm in demo mode now.
This is demo, Jeff.
Yeah.
Got it.
I don't have a mustache like that.
Yeah. Well, at least you still have hair.
Yeah.
Just saying.
John, how do you want to do this morning?
Well, we have the three J's here, and I'm the what, Jeff is the how, and Jules is the why. So I will say a phrase, a guiding idea, and then Jeff demonstrates how that guiding idea works in JMP, and then Jules adds some perspective. And I may add a few more perspectives after that. So, Jeff?
Okay. I have to do all the work?
And it sounds like I have to say everything.
Yeah, but Jeff, you're good at this. You're not just a master of ceremony, but you're also a master of JMP.
Well, I have been using it a while, yeah.
Okay, and of course, Jules, you're great at doing demos, but you're also good at perspectives. So.
I do like to talk, John, that's true.
Okay, so first guiding idea is point and click. Jeff?
Oh, wait, so like you want me to actually do all of the demo, okay, all right. So I think the idea here is from the start, JMP was designed as a point and click tool. Now, over time, we've gotten used to doing much more with it, but to prove that this is the case, this hand is going in my pocket. I'm going to use this mouse and one finger. Well, I might use two if I have to right-click, but we're going to see how good I can do. Now, you gave me some data, John, to explore, and I have not looked at this much, but I did notice immediately that for some reason you chose to give me some data about shampoo. Yeah, okay, I can see why. I know a few of you out there have as little experience with this as I do, but if I can learn from this, I'm sure that you can as well. So again, one hand, one mouse. I don't know much about this data set, but I see it's got a bunch of columns. And of course, the first thing we should always do when looking at a data set is let's just go to distribution and put a whole bunch of columns into distribution. And here we go. And of course, we see, all right, some graphs. I see the first column is a batch acceptance. That tells me I'm guessing whether, how well did the batch do. And then, some spec limits on the viscosity column. I'll bet if I click the fail bar, oh yeah, look, the viscosity, that shows me the failed lots are all the ones that are outside of those spec limits. So we begin to look at the other distribution or histograms for some patterns that don't seem quite right, like thickener supplier. It looks like that might be a problem. In fact, surfactant supplier might be. Obviously, it's got a taller bar, but I don't know. Let's go to fit y by x and look at a couple of those. We'll look at surfactant supplier and surfactant concentration. Okay. Let's put some means and do a little analysis of variance and put that line on there the way Jules was looking for. And we can begin to see, yep, there's probably something maybe going on here with one of these suppliers and perhaps a small relationship with surfactant concentration. All done point and click. I didn't need any scripting, no programming, really no prior knowledge about the data set at all. And from the start, JMP was built that way.
What's interesting is point and click we kind of are used to now, but that was revolutionary in 1989. Like the advent of the Macintosh, before then, even using a computer wasn't graphical. You were typing into a command line. And so, JMP was kind of revolutionary in that way, the idea of using just a mouse to drive a statistical piece of software. Before that, you had to memorize, functions from code books. You had a language between you and the software you had to learn in order to express. And, programming environments have their place for reproducibility, which I know we'll talk about later, but point and click gave us direct access to creating output and using the software without really ever having to learn anything.
Exactly.
Well, you have a very talented finger, Jeff. So why was point and click so revolutionary? Well, it was do it yourself. Engineers and scientists and other researchers could do their own analysis rather than handing it over to a coding specialist. So the barriers are gone. Everybody can do data analysis. Well, now we have another option, artificial intelligence. You can just type in your request in English and natural language or some other natural language, and it does something. But, might give a different answer each time, and it may misinterpret the words, different meanings, and may use a discredited source, and it will usually deliver what you ask for, but perhaps only what you ask for without the richness and details that JMP provides. And of course, you could fix all these things by adding a lot of RAG. But was it really easier typing in your request in a natural language, or was it easier just to use one finger to point and click? Of course, you mentioned the right click. Apple was so fixated on the one-button mouse, but it was Microsoft that championed the second mouse button, the right mouse button, and I call that the rise of the middle finger of Microsoft towards Apple.
I'm going to keep mine down.
John's full of jokes this morning.
So let's go to the next guiding idea, the data table. When you prepare the data, prepare it well.
Indeed. As all of you know, from day one, the data table has been central to the JMP experience. The idea that you can actually see the data that you're working with, but it's much more than just a simple table of rows and columns, and has been since version 1. Every column has a number of properties, and for example, this batch acceptance column, if we look at the column information, we'll see a new column property that was new back in 1989, the idea of a modeling type. Actually telling the software, hey, this is a nominal column. This column contains categories. We also took that idea and extended it. If we look at the viscosity column, we'll see that there are column properties there as well. For example, those spec limits get embedded into the data table. The data table is rich with metadata all about the types of data, the way the data should be treated as we move through the software, or move through the analysis. John, you talked about preparing data. We should always worry about, from the start, we needed tools to be able to manipulate the data table, to reshape it and join it with other tables. For example, I've got this finishing by batch data table, and I want to update the original table with that. And so it's a simple choose update from the tables menu. The tables menu has been around since JMP version 1, and we now have a new column new columns in the data table, the final pH and the batch time. When did the batch get finished? But it's actually in date and time. And what if we just wanted it in a date? Well, we needed a way to put formulas onto columns and transform columns with formulas. Over time, that became an even simpler option to just add a new formula column, which is the date. And we can see that formula is built for me automatically. It's simply the batch time minus the time of day, giving me just the date. So the data table becomes central to enriching your data, preparing it well, making sure that it represents what it needs to for you to do your analysis.
There's really nothing so powerful and rich as JMP's data table. If you compare it to other software like Excel, programming languages, JMP, you imbue the data table with so much meaning. The metadata you talk about, it's useful not just for your own units property that you had to show something to you, but also for JMP to understand what you mean by these different columns. And there's something about the rigidity of the table, which we normally think of as a bad thing, that actually provides a lot of value. By having the table structured, compared to Excel where you could put data anywhere in an Excel table. John Weiss has this thing he likes to say about it's just a grid of Word documents. But the data table in JMP is structured. Every column is meant to be one thing, and that means you can have units applied to it. You can have a formula that applies to the whole column rather than just individual cells that have formulas. And so the structure of the table gives it power and gives it meaning. And so because it's organized, because it's structured, unlike Excel, you're going to have columns that mean certain things, and you can operate on them in structured ways. Unlike programming environments, the data's front and center. You don't have to ask to see your table like you do in a lot of programming environments. And unlike databases, the data is ready for analysis. The metadata is built around analytic interest, not around storage. And so, yeah, the data table in JMP is so central and so powerful, in part because it's so organized and structured.
There's simply nothing else like with the richness of JMP in the data table. It's front and center, disciplined, value added, and remembered. So, on to the next guiding idea. Platform, organizing the facilities by the situation. Jeff?
As Jules pointed out in her demo, or her video from her first experience with JMP, we tried to get all of the complicated language out of the menus. We didn't really want people to have to know what's the difference between linear regression and an analysis of variance, or where what's your favorite test? Aspen-Welch, what is it?
The Aspen-Welch Satterthwaite student t-test.
Oh, of course, yes.
We all love it.
A menu that long. No, we would never do that. So we built platforms that are quick to launch and don't require a lot of information. Simple words like distribution, where the dialog box really is only looking for what columns are you interested in examining. Or fit Y by X, a powerful platform that can do multiple kinds of analysis depending on what you give it. If I use a continuous variable as a Y and a categorical as an X, and another continuous as an X and a categorical as a Y, I get 4 different kinds of analysis in that one platform. I didn't have to ask for different things. I didn't have to know what it was I was looking for. It did it automatically. And that comes from the richness of the data table.
Yeah, I mean, platforms and what you're describing here, it's all about navigation and being protective of sort of the user's attention span. I mean, navigating through software is usually the most complicated part. But I love how JMP is organized around situation. I used to always tell students, situation and not statistic. You get yourself into a context where the analysis makes sense. And that goes back to the data table. The metadata you imbued it with, telling a column that it's nominal, meant that JMP could know when you get into a platform, a version of fit Y by X, the types of analyses that make sense. A lot of software isn't organized this way. Like I said, when I was using SPSS, those menus were extensive because they listed out the exact procedure that you were trying to find. And once I learned how JMP's navigation worked, I really loved it. You get yourself into a place where the analysis makes sense, and then you move forward. And of course, you have programming environments. I think CRAN is up to 24,000 packages or something. One thing I appreciated about JMP, because I'm not a statistician, I'm a research scientist. I loved that I didn't have to pick the specific variations of analyses JMP offered. And I know it's designed by professional statistician developers who make good choices and set up good defaults for these models. And so I really appreciated that about JMP. It's protective of my attention and helps me get to the right place of the software really easily.
Yeah, the exact number of packages in R is 23,247, and each one of those has multiple methods in it. So good luck finding the one you need. So now, JMP also tried to choose the best and most respected methods available for each situation, avoiding all those other choices that many generations of PhD students and faculty have invented to secure their publication counts. Little dig there. Okay, well, as you mentioned, we try to express concepts in everyday language and avoiding the well, not completely avoiding the language of statistics when it's called for, but it aims for a balance. Well, next big idea, the next guiding idea is interactive versus plan ahead. Jeff?
This is the concept that once you're in the platform, that's where you need to make your next choice. So, for example, here with the one-way analysis of variance platform, we're looking at a continuous Y and a categorical X. We have 3 different categories. I've already put the analysis of variance, the means diamonds, on here, but the next choice is, how do I continue that analysis? Why would we give you a whole bunch of stuff initially when under the red triangle we will find the comparison of means? And we didn't use, as best we could, words like Aspen, Satterthwaite, whatever he said earlier. Each pair was a really simple concept. We want to compare each individual pair, or do we want to look at all pairs? Now, the statisticians in the world do want to know whether that's a student's T or a Tukey HSD, but for those people like me, I can understand each pair versus all pairs. So the analysis continues to unfold as I progress. As I go through the platform, I don't have to choose ahead of time what we need. JMP launches with a small amount of information, and using that information, I make my next choice.
That was the exact paradigm understanding I was missing when I first used JMP. I was used to this idea of you set everything up at the start, throw all the analysis to some processor, and get back results. So I was expecting, when I was first using JMP, I asked for something, and I'm going to get everything back. But now that I understand this, this is the right way software should work, because there's no reason to give every option right at the start, because honestly, your discovery within a platform refines your intent. It makes sense to do it this way. As you dig deeper, as you learn more, as you get output from JMP, that may raise new questions. And so giving you options at that moment so you can go further, it's the right paradigm. And it's one of the reasons I really did fall in love with JMP.
Yes, follow clues. In the old days, we had batch jobs, and I'm old enough to remember that. Things didn't happen instantly. You had to wait, and so you had to plan ahead. But things are different now, at least if your software is designed to be interactive. So the next guiding idea, statistical graphics, a graph for every statistic. Jeff?
We did want every platform to start with a picture. As John frequently says, a picture's worth 1,000 words. How many numbers could it possibly be worth? It makes it easy to make that next decision if you can see what's going on. Now, why is it important to see what's going on? Well, let's look at the classic example from Anscombe's quartet. Many of you, I'm sure, are familiar with this, but we have 4 pairs of x's and y's, and the regression line for all of them is exactly the same. Parameters are almost exactly the same, and you can see that they all look very similar. And if we show the points on the first one, it's kind of what you would expect. A sort of random scatter around the regression line looks reasonable. But let's look at the next one. If we show those points, oh, well, that doesn't look so good. If it weren't for this one point way up here, this would be a perfect fit. Let's look at the one down here. Whoops, sorry. Well, that one clearly should not be a line. That's a polynomial, and it fits nearly perfectly. And then finally, what's going on there? How could that possibly be? Well, if we drag the axis over, what's the name for this, John?
Leverage.
There you go. It's pulling that line up in that direction. So it's important always to look at the graph, and we wanted a graph for every statistic. That same kind of example can be seen with all kinds of data. Here's another set of pairs of x's and y's, and if we look at the shapes that these data take on, you'll see the lines are all the same, but the data clearly is not the same. I mean, it gets so far as even our logo fits that line.
Is that real data?
This is real data. We actually, that's how we got our logo. Yeah.
Something I've heard John say is statistics have tunnel vision. So a graphic is really wonderful because it exposes interesting things about the data like this, where if you hadn't been looking at it, your assumptions of a linear model are entirely violated here, but the statistical graphics make that clear. And so I did love the perspective, that JMP has, where, statistical graphics make complicated structures make more sense. And when JMP was first started, it was actually anomalous to have a graph with every stat. I mean, it was expensive to produce. A lot of especially command line systems, printing out graphics was ASCII, and you had to do a lot of work to develop them. And so it was novel to have this kind of perspective. But it's amazing in JMP. I mean, to really make sure that you see and understand the statistical structure through a graph and visualization was really revolutionary.
Yes, I remember the old days of printer graphs and so on. And graphics was so undervalued back in the old days. I seem to be the old man here. So. Well, a graph can be the difference between a hit and a miss for something worth discovering. Well, the next guiding idea is dynamic linking by rows. Jeff?
Because we put the data table front and center, all of a sudden, then the concept, the idea of selection became a feature of the data itself. It was no longer just relegated to, I can look at the data, but I can't touch it. So getting back to that, oh, I closed Anscombe. I meant to keep Anscombe open. Let's get that back here real quick. Getting back to our regression where there clearly is an outlying point, once I select that row, or that point in the graph, it's of course selected back in the data table as well. And because it's selected, now I can imbue the data table with even more information. I could color that point red and have it be colored red in every graph. I can exclude and hide that row, or just exclude that row and refit the regression to see, does it fit perfectly after that? And indeed it does. Through dynamic linking, we can make discoveries through subsets of data and through summary data sets. So for example, let's look at a classic data set, the nicardipine data set, and let's do simple things like a summary table by, a little bit wider here, by the, I lost my column there, the subject and the, forgot which ones I wanted to use. It's the, no, body system. It was the body system table, or the body system. I'm going to group those two. The question I have here is, which of these subjects had the most different body systems affected? This now I know that this unique subject had one time where they had a nervous system disorder, but I want to know which of these had the most different ones. And so I do a summary of the summary by unique identifier, and now I know that there was one poor person in this study. If I sort descending, or not one person, there were a number of people who had 10 or 12 different body systems affected. And as I select them in the summary table, they're selected way back in the original table, and I can begin to filter down by that selection and see more information about those individuals.
It's really powerful, attention being a first-class state within the software. And part of it goes back, like you said, to the data table, the structure, the fact that rows also have metadata, and selection is one of them. But the fact that your attention persisted across all the different surfaces in the software, what you just did was enormously complicated. Being able to do the summary of a summary and then find those rows, to do that in other software or in other environments is actually incredibly complicated. But you're able to do it also just point and click. But it's magical because that connection between all the rows exists within graphs, it exists within tables. It was one of the things that I think was most impressive. I accidentally clicked a histogram bar early on using JMP, and I was like, oh my gosh, those rows got selected in the table. And then it suddenly makes that connection so clear that, oh, those rows are being manifested in that graph. Really incredible.
Well, other products just don't do this. They do static graphs or maybe customizable graphs, but not dynamically linked the way JMP is. Other packages just throw the data over the wall to the graph, and the graph and the data table do not speak to each other. But in JMP, the graphs and the data hold hands and talk to each other. So, next guiding idea, exploring the prediction space. The model fit is just the beginning. It's what you do after the fit that's the most valuable. Jeff?
Indeed. We want every part of JMP to be an analysis, to answer a question. And we all know after you fit a complicated model, you get a lovely prediction expression. Can anyone in this room tell me what this function looks like? No, we need a visualization. And so we created the prediction profiler, where we can explore and understand the relationships represented by that complicated model. We can begin to see interactions between, for example, mix time and mix speed. In real time, we can begin to explore and understand how this model works. What are the relationships? We can have a rational conversation about the trade-offs that feed into how we might optimize these responses. So if I maximize desirability, now I find that, yes, I can get to a pretty good approximation of my target. I can probably make shampoo that meets my specification. But I noticed that the various suppliers are different. Well, through the profiler, I can actually look at the, I can lock the suppliers and then maximize for each grid point and get solutions for each combination of suppliers just like that. If I couldn't see that prediction profiler, I wouldn't know that that's a thing that I had to do. Plus, the point and click makes it really easy for me to.
The profiler is really incredible. I mean, a couple things I'll say about this. It's an extension of a graph for every statistic. But of course, for a model, the graph being static is really complicated. I mean, the profiler is incredible. It's a cross-section of your Y space across the factor space. It's your response plane cut up into different segments. But the fact that it's interactive changes things entirely. Remember the first class when I was teaching bilinear interactions, and what Jeff is doing right now, this was the way I explained to students what that interaction term was. It's, as you change the x for this variable, the relationship between y and another variable changes. But you get to see it because you're interacting with it. So not only is this a graph, interactive graph, that makes clear, complicated statistical structures, but the interactivity, it becomes an interaction surface. You're actually able to ask questions of your data and move forward. So again, in this model of your evolving intent based on your discovery. And then the optimization, and there's so much deep into the profiler for simulation and desirability. But even on just the pure surface here, being able to touch your model, there's really nothing else like it.
Well, profilers are cross-sections of the prediction surface, or slices. So if you slice across a factor, then you get the prediction profiler. If you slice across a response, then you get the contour profiler. And then there's specialty profilers, the mixture profiler, the surface profiler, the design space profiler, and more. So lots of features, especially for optimization and so on. So on to the next guiding idea, the integrated interactive service. Jeff?
Absolutely. It's somewhat revolutionary in 1989, the idea that we might have close all below. We might have a report platform or report surface where as we scrolled through it, we didn't lose context for what we were looking at. In the old days, pages of paper, you turned the page and now wait, what was I looking at? Were these parameter estimates? Were these contour estimates? What were they? Because we have the sticky titles, now we can remain in context for what we're looking at. But the surface itself is also interactive. The tables themselves know they are tables. Right-click on a table, and I can make it into a data table. It becomes a first-class citizen in and of itself. I can take the results of an analysis and turn it into data for doing the next analysis. There are also, I showed a simple thing earlier with the Anscombe data, the idea that the surface itself is interactive. Simply grab an axis and drag. You can change what you're looking at in real time. No dialogues to go through. It is touchable, it's relatable, you can actually physically grab hold of it.
We forget that. You can just, dragging axes in JMP is so obvious to JMP users, but it is something that you actually have to, you have to go and recreate a graph in most systems because output is final in a lot of products. And in JMP, the outputs you see in reports, it's really never final. There's always something you can change and interact with and you can dig deeper. So the surface being alive in this way, and also responsive to you. Like you said, if you right-click in different places, you'll get different right-click menus. When you're first using JMP, that may be a little startling because you maybe are thinking, where do I click to get the right thing? John always likes to say to new users, like, make sure you right-click everywhere, which is very important because the surface is listening to you. Where you click is contextual information, and so the software is going to give you the right options. Again, based on that idea, we're not trying to overwhelm. We're trying to give the right options at the right time based on the context that we understand.
Yes, with the power of double-clicking or with the talent now that JMP provides to your middle finger, you can do a lot in customization of your response or your report service. So next guiding idea is analysis at scale. handling multiples and subsets and large problems.
Indeed. The simplest form of that is with a bivariable. So if we look at, back to our shampoo data, if I go to the Analyze menu and choose fit Y by X, and I want to look at that relationship between viscosity and surfactant concentration, but I want to look at it by the surfactant supplier and the thickener supplier, I all of a sudden have lots of analysis all at once. I have lots of graphs. And to be able to quickly interact with them, things like the broadcast of a command by holding down the control key and choosing to fit a line, it will fit it against all of those relationships all at once. To be able to do that quickly and work at scale and understand how we can move across different kinds of analysis quickly. That extends to things like the screening platforms that you'll find with this semiconductor data, for example. Being able to quickly do process screening across hundreds of variables all at once. And again, if we want to, turn it into a data table and continue the analysis that way. Everything works the same way, regardless if you're looking at small relationships or big relationships.
Yeah, two observations here. First, the by groups, that's incredible. Your analytical intent just generalized without multiplying your effort. You were able to apply basically the same analysis off partitions of the data. And data filters will do the same thing, as will column switchers. And so the idea that there are affordances built directly into the software and the interface that lets you ask the same question across many different spaces of your data table, that's incredible, and it's such a time saver. Second thing is, JMP is in memory. It's sort of built around the idea that you have enough memory on your computer to load all the data in and process those vectors in real time. And so something magical about JMP is, you just did only maybe 50 regressions, I don't know, not a huge amount, and that was instantaneous. You can do that in JMP with thousands of regressions, and it's still going to be almost instantaneous. We have brilliant statistical developers who work tirelessly to make these things so fast, not just in computational multi-threading, like of course we take advantage of modern protocols for that, but there are some statistical developers who spend weeks trying to get their routines faster and faster because it's just an obsession of theirs. Sorry, John. He really does do this. But he cares so deeply about JMP being so fast, so when people throw enormous problems at them, it's going to actually run quickly and be fast and feel instantaneous. Again, for the distance between your intent and your output to feel as fast as possible. And so JMP is pretty magical with these huge problems of scale.
Well, researchers often have large, complex data, and they have large, complex questions about the data. So exploring data at scale efficiently is important. On to the next guiding idea, remembering. Jeff?
The data table itself helps remember qualities about the data. It's imbued with this richness that we talked about earlier. And for the first 3 versions of JMP, point and click was the only way we could work. The best thing we could do to remember things was to embed it in those properties of the data table itself, so the next time we did it, it looked similar or behaved in a similar way. And then in version 4, we sort of got tired of doing the same thing over and over again, and so we created the scripting language. You all are all aware that through the activity log, you can see everything that JMP has done. It's remembered exactly what all the steps that I've taken, and so we encourage everyone to take advantage of that by doing simple things like, once you do an analysis, if it's something that's important to you, save it to the data table. Save the script to the data table. Under the red triangle, save script, save to data table. You can remember exactly what's happened. In fact, through this whole demo that I've been giving, I've had a workflow running, and I can actually repeat everything that I've done with no hands. It's that simple. We want JMP to remember what you've done. We want you to help JMP remember what you've done.
This is actually a pretty special part of JMP. It's interactive software, it's point and click, but there are times, as you said, where you really have to recall what you've done. Maybe it's because of regulatory reasons, maybe it's time savings because you do the same work every day. And so there's places in JMP affordances for saving individual reports. But also, we know a lot of our work is a process. It spans many actions in the software, which of course is what led to Workflow Builder, the idea of capturing all of that, but doing it in a way that's still point and click. The fact that you can just hit the record button, let JMP observe itself, and then replay the actions back. And so being able to get kind of the best of both worlds here, interactivity and point and click so that you can drive JMP in an exploratory way, but then you have all the value of basically code in your exploration becoming specification.
So remembering what you do, JMP didn't always do this, but now it does. So now we've covered a lot of guiding ideas, the 10 main ones, but there's a lot more guiding ideas in JMP. There's plenty more. A very important guiding idea is about design of experiments with custom experimental design. You describe the situation, and the computer makes the optimal design for that situation. And there's lots of features to go with that, like minimal aliasing, supersaturation, handling split plots, and more. This is one of the very best features of JMP. Makes it world-class. Another guiding idea is using drag and drop. Instead of launch dialogues, when you go into Graph Builder or Tabulate, you just drag and drop variables into role places and to make the graphs and customize it. So an alternate way of making a report. Another guiding idea is providing for more advanced users with JMP Pro. Pro adds specialized features, more predictive modeling, functional data analysis, the new Bayesian optimization, and many other things, while keeping base JMP for most analytic needs. Another guiding idea is publishing results to share with others with JMP Live, where the results are updatable with new data. Another guiding idea is supporting preferences and presets. So when you want JMP to adapt to how you want to do things, there's a way to do that with those facilities. Another guiding idea is lots of help everywhere, especially including the search facility. So control comma or command comma is your friend. It's your go-to accelerator, so please try it out. If you ever have a puzzle for navigating somewhere, just control comma and you got instant help. And another guiding idea more recently is data connectors. So it multiplies the ways you can access external data sources and make it easy. So in summary, JMP is tuned to the mindset of a detective looking for discoveries rather than a lawyer just trying to prove a case. An explorer scouting the data rather than a scripter coding for a prescribed report. And discovery is our theme. It's in our company name. It's in the name of this conference. It's about getting lucky by the power of exploration, doing more things, and having more opportunities to see things in the data. So there you have JMP and the guiding ideas.
Okay, I can take it from here.
All right, thank you,
guys. Jeff. All right, so just as a quick review, we saw that point and click brought us intention directly to action. The data table, structure that carries analytic meaning. We saw that platforms were analysis organized by situation, aware of the context that we put into the data table. Interactive showed us that we can discover without planning everything first. Statistical graphics were both explanation, but also interaction surfaces all on their own. And that was helpful with dynamic linking because our focus was moving seamlessly across views. In exploring predictions, we saw that models could be understood visually and still explored interactively. The integrated surface gave us reports that were never final, so that exploration can continue in place. With analysis at scale, one question could be applied multiple times without exploding our effort. And finally, in remembering that exploration can become specification. Now, as John said when we started, my role up here is meant to be largely synthetic. And I understand that to mean to take all these ideas and to find deeper meanings among them, which I have to say is kind of intimidating because my job is to find deeper meanings, and the founder of the software is there to judge whether I did that or not. So a little intimidating. And so, I was looking at all of these, and I was trying to think, what other things underlies these? If these are all the mind of JMP, what deeper framework maybe connects all of these? As I spent a lot of time wrestling with this idea, and it was maybe like 4 or 5 weeks ago, I had a meeting with Jeff and John where we were going to go over this plenary, and I was going to pitch them on sort of what is my ending bit, what are the through lines that I saw among all of these. And I told Jeff and John, all of my ideas, and I would love to say that John's reaction was like, oh my God, Jules, you're such a genius, that's perfect. His reaction wasn't exactly that. It was like, I don't know, I think you kind of missed the mark, which to me was devastating. To be clear, John was very nice about it. Of course, John always is. He's very conscientious. But there's nobody whose, respect I want to earn more than John Saul's. Jeff was in this meeting too, but Jeff already knows I'm a dummy. Anyway, so I thought to myself, okay, that wasn't it. So I went back to the drawing board. And so I asked myself, this is the picture I'm imagining. There's this mind of JMP. What things connect it? And I realized that an assumption about this picture was blocking me. It was stopping me from kind of understanding what really does connect all of this. Because this picture is incomplete. It's missing something. It's missing someone. Do you remember why there's no vowel in JMP? It needs you. It needs the user. It needs the user down there. But the user isn't in the corner, blocked from JMP. Right? There's something connecting the user to the mind of JMP. There's a channel. There's an interface that's carrying analytic intent from you to the software and bringing back results and understanding so that you can make meaning of what you asked for. And so what we've been exploring is not exactly the mind of JMP. It's this channel and what we've seen are founding principles, foundational bits, among many others, that form this channel and this interface that exists between us and the software. And so taken from this context, we're talking less about just the mind of JMP and more about our communication with the software. And communication's about language and understanding the language of JMP. And that really felt to me like I was onto something here, because if you think about language, it's not about being an expert. Of course, as you learn JMP, you do gain expertise. You understand where things are. You understand how to click the menus and what things it does. But there's something more about learning JMP that doesn't feel just like expertise. And in this framework, in communication, the way we describe it would be fluency. When you're fluent in a language, you understand how to express to another mind something in a way that that mind can understand. And you're able to, if you're fluent, get the response and really deeply understand what it meant. To be fluent in JMP is to have that feeling when you communicate to the software the things you want it to do, and it knows just what you're trying to do. And you get back responses that you completely understand. And so to have native fluency in JMP is that moment where it really feels like there's no distance between you and the software. Your interaction with it gets you exactly what you're after. I explained all of this to AI because I wanted a video of what native fluency looks like in JMP, and I have to warn you, it's a little more extreme than I was hoping for, but here was AI's take on this. So this is native fluency with the software. It just hits you with analytic meaning. So it's a bit more intense than I maybe was hoping for. But I think it does capture to some degree what it feels like sometimes when you're deep in analysis with JMP. It really feels like it's understanding you. And I mean this seriously. When you get to that fluency level of JMP, that there really is no distance between you and the data, it stops feeling like using software and it starts feeling like a dialogue about your data. It feels like a conversation. It feels like you're talking through with someone you've known for your whole life what you're trying to understand, and the responses all make sense. And so, in this conference, we're all here from R&D to listen. If there are ways that you can think of for JMP to understand you better, for ways that it can do things you need it to do, or if there are things that are missing or you don't like about how it understands you, please tell us. Because I can promise you from R&D, there's nothing we love talking about more than JMP, but we also really love listening. So enjoy the conference. Welcome to Discovery. Thank you so much.